Do you know why Java is called a platform-independent programming language? Java programs can run on any machine because of a key component known as the Java Virtual Machine. Before diving into the details of the JVM, let's first understand bytecode. Bytecode is a set of instructions for the JVM. When we compile a Java program, the Java compiler converts the human-readable Java code into bytecode. For example, if you have an animal.java class, after compiling, it becomes an animal.class file. That file is nothing but bytecode. This bytecode is platform independent, meaning it can be executed on any operating system that supports the JVM. However, keep in mind that the JVM itself is platform dependent. You must install the version of the JVM that is compatible with your operating system. Once the bytecode is ready, the next step comes into picture with the class loader. The class loader searches for the .class files in specified directories or archives like JAR files. When the file is found, the class loader reads the bytecode and loads it into the JVM's runtime data areas, such as the method area, where class information is stored. After loading, the JVM verifies the bytecode to ensure it adheres to Java's security constraints and does not compromise the system. Following verification, the execution engine takes over. It can interpret the bytecode by reading and executing one instruction at a time, which makes it possible to run code without needing a complete ahead-of-time compilation. To boost performance, the execution engine also employs just-in-time compilation. In this process, frequently executed sections of code are compiled into native machine code at runtime. This native code is then executed directly by the processor, significantly speeding up the overall execution of the program. For example, consider the following loop. Since this loop runs 10,000 times, the JIT compiler may detect it as a hotspot and optimize it by compiling it into native code, eliminating redundant checks and making execution significantly faster.